Hey everybody, I wanted to spend a little bit of time talking about reactions and types of reactions. And this video is going to focus on decomposition reactions. But before we get started, I wanted to spend just a little bit of time making sure that we know the vocabulary of a reaction. And so what I'm going to do is I'm going to split the reaction kind of mentally. I'm drawing mentally what I do in my head. And I split this, and so basically on the left-hand side here, these are called reactants. These are the things you start with or mix together in a chemical reaction. Okay, so we start with these things. On the right here, these are the products. These are the things that are produced or made in a chemical reaction. You end up with these things. This is the desired ending. Now, in general, the reactants are on the left and the products are on the right, but the more technical way of describing this using the arrow here is that the arrow always points at the products. That the pointer end of the arrow will always point at the products. That means the blunt end of the arrow is kind of always at the reactants. And so every once in a while you'll see a reaction that is written backwards, where you have the reactants here and the products here. But reactants and products are typically on the right, or the left and the right respectively. So the diatomic elements, since we're talking about compounds and reactions here, we have to know maybe how these elements look. And so there are 7 elements that exist in nature not as one atom, but as 2 atoms bonded together. And so for something like hydrogen, hydrogen is H2. When we find it in nature, we find it as 2 hydrogen atoms put together. Think back to biology. Biology, when we breathe in oxygen, we never wrote it as O, we wrote it as O2. When we see oxygen in nature, oxygen's not O, it's O2. The same is true with nitrogen, N2. And so I remember this using the mnemonic device. I just pronounced this out, and it's Honkelbrief. This is chlorine, and this is iodine. So this is Honkelbrief. Okay. Well, these guys form neutral elements. They're not ions. They form neutral elements. F2. And we go from there. But enough about all of that. Let's start talking about decomposition reactions. And so this is pretty much the opposite of a synthesis reaction. And this is where you have a reactant that breaks down, forming 2 or more products. See, there's a synthesis reaction. And so you end up forming 2 or more products. So the idea is we take this complex thing and we break it into its parts. Its parts don't have to be elements. It's just something that is smaller than what we started with. And so this is kind of the typical, a typical decomposition reaction. And this is hydrogen peroxide, H2O2. And now for now, we're not going to worry about this 2 in front of the in front of this, or this 2 here. But the idea is that peroxide breaks down. This is how it works when it cleans out your cuts and stuff, is that it forms water in O2. O2 are the bubbles that you see. O2, notice it's not O, this is a diatomic element, and so we form O2. Now we're going to have to balance this and notice the number of oxygens, and that's what these 2s are. And you probably have some familiarity with balancing reactions. But this is this is a decomposition reaction, where we started with something and we formed 2 or more products, because if this were something else, we could form something plus another thing. Like, there could be things all the way down the line. So that is a decomposition reaction, and I hope you have a great day.